Welcome to the ET335 NAND NOR Inverter lab presentation. Okay, here we have our multi-sim, and we're going to prove our truth table for both a NAND and a NOR. So let's start with the NAND. So we're going to open up our TTL. We're going to go to 74LS, and I'm going to grab the 7400. And I am going to use every one of them. So A, B, C, and D. And the first thing let's do is cancel out of that, close that out, and let's go ahead and go to View and go to Zoom area. There we go. That looks better. Well, I think we can see that much better. Alrighty, so we're going to need to put highs and lows in here and an output. So first thing let's do is just grab that output. So we're going to go to Indicator. It's a little 7-segment looking icon up there. Let's use orange. So let's go ahead and put 4 of these in. Good. And let's close out of that, recenter it. And what we're going to use for our logic is we're going to just go ahead and use power, VCC, good. And it's going to give us some messages that we've got hidden power, which is okay. And let's go ahead and grab a ground. That's going to be our low. So, get rid of our error messages. So, 5 volts is a 1, a high, and ground is going to be a low. So let's go ahead and start. So our first one's going to be, let's move that over. The first one is going to be 0, 0. So let's put in 2 grounds. And let's go ahead and flip him vertically so I can get a clean shot. Good. And this guy is going to be a 1, 0. So let's borrow this one. Good. And let's copy this guy. Good. Okay, let's go ahead and hook up a probe. Click. And let's go ahead and see if I can move the little over smidgen without messing everything up. Good. So this one is going to be a 0, 1, and this one's going to be a 1, 1. So we could take that guy and let's move him. He's just in the way. So we could take these titles and move around just by clicking on them. So since we're going to have a 0, 1 here, let's move this down because I think they're going to collide. Alright, so we have a 1, and we're going to need a top 0 over here. So let's paste it. Okay. And this guy, let's copy it. Paste it. We're also going to flip him vertically. Flip vertically. So now he's in the way too. So now we've got a high, high. 2 VCCs in. And let's go ahead and copy this guy. Yeah, let's see if we can move that guy. That's the problem when we get in here. We're going to get them all mixed up here. So let's see here. There we go. And what do we got here? We got a little. Let's just get him out of the way. He's just nothing but trouble. Okay, let's hook up our probes. Okay, so these probes are going to light when it's a high. And 2.5 says that at the minimum voltage it'll turn on. It's 2.5, which is just a smidgen above the valid minimum for a high out. Okay, now let's fire it up. Try again. Let's get rid of our messages. And now let's take a look at here. We have, what's our unique condition? 1 equals 0. Okay, 1 equals 0, and that's correct. 0 would be a 1. 0 1 would be a high 1, and high and low 1 0 would also be a high. So this proves our truth table. So let's do one more thing here. Let's see if we could shrink it up a little bit so I can get, let's zoom out. There we go. Good. So let's turn it off. Get rid of our probes. Window. Nope, that's going to take out my NAND gate. There we go. Alright, so let's get a DMM and we're going to test for the minimum voltage and maximum voltage. So we're going to check and see what a high and a low is with our virtual devices, which I think are going to be ideal instead of real. So let's try it. A meter, let's borrow a couple grounds. And let's try it. And open them up. So we have a 5-volt high and a 0-volt ground. Not even close to the nominal values that we normally get. So nominal, a high is about 2.4 and up. Okay, that's why they set it 2.5. So a valid high will be from 2.4 to 5 for a TTL device. And this one is going to be from 0 volts to 0.8 volts for a valid low. Okay, we're back to our multi-sim. And I've got rid of the DMMs and I replaced the probes back. And what we want to do now is to demonstrate the truth table for NOR gate. And we can completely redo this circuit, which is not good. So let's go ahead and click on it, and we're going to replace components, and we're going to go back up to 7402, OK, and select A. Right click, replace components, 7402, OK, B, replace components, 7402, OK, C, and replace components to OK, D. Alrighty, so let's go ahead and start it up and see if we could redo our truth table. And here's our unique condition: 0, 0 equals 1. Our probe's on. 1, 0 equals 0. 1, 0 equals 0. And 1, 1 equals 0. So this is our truth table proven for a 7402 NOR gate. Okay, we're back again, and now we want to test the truth table on an inverter. So let's go to TTL 74 and let's go down to a 7404 because we do not have a 14 in my LS, so that'll work fine. So let's go ahead, and we're going to need 2 of them. Okay, and close out, and let's go to view, and let's go ahead and zoom area again so we can see what's going on. There we go. So we're going to need a ground, and we're going to need VCC. and it's going to tell us that we have internal power, which is good for me. So we got a low and a high, and let's grab a couple probes. Back to our indicators, and let's do blue. No reason, just okay. And let's move this down a little bit. Let's go ahead and power it up. And we have a low in, high out, high in, low out. So that proves our truth table for an inverter. Okay, we're going to prove that a doubled input NOR and a NAND can work as an inverter. So let's go ahead and let's get rid of that gate. Get rid of that gate. Alrighty, so let's go back to our TTL and let's grab a 7400. Okay. So let's go ahead and test that. Hook that up. So we're going to tie these two inputs together. And we're going to tie this guy. Okay, so let's see if he works as an inverter. So let's fire it up and get rid of our messages here. So we have a low in, and we're going to get a high out. We have a high in and we'll get a low out. So let's go ahead and see if I could go ahead and just swap these out for a NOR gate. Oh, very good. So let's go ahead and fire it up and see what we get. And again, a low in gets us a high, high in gets us a low. Good. So that proves that works as a inverter. So let's try the other gate. So let's add an or. So let's replace. And let's just go to the closest one, a 74.8, which is an and replace 74.08, and we have an and. So let's go ahead and turn it on, find out what's going on. And here we have high in, high out. So an AND gate will not work as an inverter in this condition. So let's try one more. Let's try an OR gate. Replace, and it's a 7432. And we got an OR. $74.32. Okay. B fired up, and again we have one in, one out. That is not an inverter.